Hello students, welcome to the channel. In the Target 750 Plus series, we look at advanced problems from topics that you're likely to see on the SAT and ACT math sections. In today's video, we look at ratios, rates, and proportions. Question 1. Sam took 5 tests as part of his final assessment. The full marks in each of the 5 tests was the same. His scores on the tests were in the ratio 6 to 7 to 8 to 9 to 10. If he obtained 3/5 of the total marks on these 5 tests, on how many tests did Sam score more than 50%? Okay, so let's assume that the full marks on each of the 5 tests was 100, right? And let's say that Sam's individual scores in the tests were 6x, 7x, 8x, 9x, and 10x, right? Because the scores are in these ratios. So let's assume that these are the scores. Now he obtained 3/5 of the total marks, right? So if each test is 100, the total marks on the 5 tests would be 500. And Sam scored a total of 3/5 of 500, which is 300, right? And that is simply the sum of these individual test scores. So 6 plus 7, 13, plus 8, 21, plus 9, 30, plus 10, 40. X should be 300. So X should be 300 by 40, which is 7.5. So X is 7.5. So what are his individual scores? 6x, 7x, 8x, 9x, and 10x. So 6 into 7.5, 6 into 5, 30, 45. 7 into 7.5, 5 carry 3, 52. 0 carry 4, 60. 5 carry 4, 67, and 75, right? So on the first test, he got 45 out of 100, 52.5 out of 100 on the second, 60 on the third, 67.5 on the fourth, and 75 on the fifth. So on how many tests did he get more than 50%? 1, 2, 3, and 4. On these 4 tests, he got more than 50%. So the answer is option C. Okay, let's go to the next one. 3 boys agree to divide a bag of marbles in the following manner. The first boy takes 1 more than half the marbles. The second takes 1/3 of the remaining number. The third boy finds that he is left with twice as many marbles as the second boy. What is the original number of marbles? Okay, so let's say that the original number of marbles let's say that that is X. So what is the first boy taking? He's taking 1 more than half the marbles. So the first one is taking X by 2 plus 1, right? So he has taken 1 more than half the marbles. So how many remain for the second and third boy? That will be X by 2 minus 1, right? Because of the half, he took 1 more than that. So of the half, 1 less would remain for the other 2 boys. Now, the second boy takes 1/3 of the number remaining. So the second boy takes 1/3 of the number remaining, which is X by 2 minus 1. So that's X by 6 minus 1 by 3. So how many remain for the third boy? For the third boy, this is what was available, X by 2 minus 1. And this is what the second boy took. So that will be X by 6 minus 1 by 3. So you have X by 2 minus X by 6. So that's 2X by 6 minus 1 plus 1 by 3. So that becomes 2x by 6 minus 2 by 3, right? So that is how the third boy gets. Now, it's said that the third boy finds that he's left with twice as many marbles as the second boy. So the second one got how many? Second one got x by 6 minus 1 by 3. So twice of that will be 2x by 6 minus 2 by 3. But that's exactly what we got for the third boy. So here we see that regardless of what x is, this situation will always obtain. If the first boy takes one more than half the marbles, if the second boy takes 1/3 of the number remaining, then the third boy will have twice as many marbles as the second boy. That will not depend on x. So the original number of marbles cannot be determined. It could be any number, and this situation will always obtain. Okay, let's do question 3. The number of geese in a flock increases so that the difference between the populations in year n plus 2 and year n is directly proportional to the population in year n plus 1. If the populations in the years 1994, 1995, and 1997 are 39, 60, and 123, what is the population in year 1996? So the difference between the population in year n plus 2 and year n is proportional to the population in year n plus 1. So x minus 39 is proportional to 60, and 123 minus 60 is proportional to x, right? Because n plus 2 and n, so this is n plus 1, n plus 2 and n, so this is n plus 1. So I can say that x minus 39 is 60k, right? So I replace the proportionality sign and use a constant. And 123 minus 60 is 63. So 63 is equal to kx, right? So just using the proportionality sign. Now I have two equations and two variables. So I need to find the value of x. So let me divide the two. X minus 39 by 63 is 60k by kx. So the k is cancelled. Cross multiplying, I get x square minus 39x is 63 into 60. So x square minus 39x minus 8 carry 1, 3780 is 0. So I get a quadratic equation. So let's try and solve that. I'll just clear this. Okay, so my quadratic equation is x squared minus 39x minus 3780 is 0. So let's solve this on the calculator. Okay, so we get x equal to 84 and negative 45. Since x is the population in 1996, it has to be positive. So the right answer is option B. Question 4. In an H meter race, Andre is exactly D meters ahead of Bruno when Andre finishes the race. The next time they race, Andre sportingly starts D meters behind Bruno, who is at the starting line. Both runners run at the same constant speed as they did in the first race. How many meters ahead is Andre when he finishes the second race? Okay, so there is an H meter race. Let's say this is H meters. And Andre is exactly D meters ahead of Bruno. So let's say Bruno is here and Andre is here. So this distance is D when Andre finishes the race. So the time that Andre took to run a distance of H is the time that Bruno took to run a distance of h minus d, because this distance is what Bruno ran in the same time that Andre ran the whole distance. So what is the distance for Andre? It is h. Let the speed for Andre be sa. And the distance for Bruno is h minus d, and the speed for Bruno, let it be sb. So h divided by sa is h minus d divided by sb. So that's one equation. Now they race again. And this time, Andre sportingly starts d meters behind Bruno, because Bruno is at the starting line and the distance, initial distance is the same, right? So let me just draw this. Yeah. So this time, what is the time that Andre would take? The time that Andre would take would be the total distance for Andre divided by speed for Andre. The total distance for Andre would be d plus h this time, and his speed is a, right? And in this time, this is the time that Andre has taken to reach the endpoint. In this time, the distance that Bruno will cover is Bruno's speed into the time. So that's Bruno's speed into time. Time is d plus h divided by sa, because it's this time in which Andre has reached the finishing line. So the same time, how much will Bruno cover? We need to find. Okay. Now, SB over SA, we know from this one, SB over SA is going to be H minus D over H from this equation, right? So I can plug that here to find the distance that Bruno covers. So the distance that Bruno covers will be D plus H multiplied by H minus D over H, which is H squared minus D squared over H, because A plus B into A minus B is A square minus B square. Okay, so we know the distance that Bruno has covered and we know the distance that Andre has covered. So how much is Andre ahead of Bruno? Let's figure that out. So Bruno has gone this distance, dB. So the distance between Andre and Bruno, because Andre is here, will be, let's say x. So x will be h minus dB. X will be h minus dB. So that's h minus h squared minus d squared over h. So that's h squared minus h squared plus d squared over h. So that's just d squared over h. So that's option B. So I would encourage you to go over the explanation one more time, because this question 4 was a particularly hard question. But the idea to do this drill is to get you comfortable with any kind of problem that you might see from ratios, rates, and proportions on SAT or ACT math. Hope this exercise was useful. If it was, hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to make. I'll see you guys soon. Take care. Bye-bye.